Hello everyone and welcome. We're taking a look at this Thatquiz for this week's lesson, and it's called Intro to Functions. So you're going to find your name in the drop down menu, and as always type in that password GCVS all lowercase, and that should get you logged in. So what we're looking at this week is functions. And a function, this is just a rule, right? And it relates to two quantities, so that when you plug in an input, which is the same as an x, right? Our input is our x value. You will get exactly one output, which is our y value. So the domain, this is the set of all possible input values. And then the range is the set of all possible output values, right? We're looking at, we plug in an x, all the x's that we can plug in are our domain, and everything that we get out after plugging those values in are all of our outputs or the range, okay? So go ahead and hit OK. The domain is the list of all possible inputs. The inputs are usually represented by X, and they are the independent event and are usually the cause. The range is all of our outputs. They are usually represented by Y, and they are all of the dependent events and are usually the effect. Right? We plug something in, we get something out. Cause and effect. Go ahead and hit OK when you're ready. So this first question says, is 2, 14 a solution of this equation? So first of all, the first number is always your x. The second number is always your y. Alphabetical order, that's a way that you can remember it. So if we have this equation, y equals 5x plus 4. So what this is saying is the rule is we take a number 5, we multiply it by our input, and then we add 4 to it. That's the rule. Multiply by 5, add 4. So let's take this input of 2. 5 times 2 plus 4. Well, 5 times 2 is 10, plus 4 is 14. So yes, that is true. We plugged in a 2, we got out a 14. So this first one is yes. Go ahead and click yes, and then go ahead to the next one when you're ready. Remembering that as you're working through these problems, if you need to pause the video at any point, you can. Go at the pace that works for you, okay? Is 0, 4 a solution to this equation, y equals 5x plus 4? So it's the same equation, so our rule is still multiply by 5 and then add 4. So when we take that number 0 and plug it into our function, when we multiply it by 5, we get 0. 5 times 0 is 0. And then we add 4 and we get 4. So when we plugged in a 0, when we plugged in a 0, 0 plus 4 is 4. So yes, this is also true because that is the output that we got there, 0, 4. Our y value is 4. Okay. Go ahead and push to slide 3 when you're ready. Slide 3, we have this coordinate 2, 3. Here's our x. Here's our y. So we have a new rule. This rule is 3 times the x minus 4. So we take our x value, multiply it by 3, and then subtract 4. And we're wondering, after you do that, do we end up with this number 3 as our output? Well, 3 times 2 minus 4. 3 times 2 is 6, minus 4 is 2. And 2 is not the same as 3, so this is an example of it not being a solution because we got an output of 2. So the real solution is 2, 2. right? When you plug in a 2, you get out a 2. Go ahead and hit OK and push to slide 4. Determine if each relation below represents a function. So does each input have only one output? So as long as we have no repeated x values, we're good. So our x values are 1, 2, 3, and 4. Those are all different, so we don't even need to look at the y values. All of our x values are different, so we're good. This is definitely a function. So you can hit yay or yes, and then hit OK. For this next one, it's looking for the range, which is our outputs. And so our range is our y values. So we have 3, 4, 5, and 6. This is our range. So we can see that here in our second option, giving us the range of 3, 4, 5, and 6. And then hit OK. And for the next one, we're looking for the domain, or our inputs. So what did we plug in to get those outputs? Well, we plugged in a 1, 2, 3, and a 4. So there's our inputs, 1, 2, 3, and 4. Go ahead and hit OK and next. Is this a function? So again, we're looking at the x values. That's what tells us. If we have a repeated x value, that's bad. Here we have a 1, then we have a 2, then we have a 3, and then we have a 4. Those are all different. So this is totally fine. This is a function. We can hit yes. It passed our test. List the domain for that function. So the domain is our x values. So our domain here is 1, 2, 3, and 4. So we're selecting 1, 2, 3, 4. We just list them in numerical order from least to greatest without any repeats. Beautiful. And the next one asks for the range. So our range is 3, 3, 3, 3, 3. But again, we don't need to list any repeats, so we can just represent the whole range as just 3. No matter what you plug in, you always get out a 3. And then hit OK when you're ready. Determine if each relation below represents a function. So we look at our x's. I see a 1, a 2, and then I see 2 3s. So this is a problem. Uh-oh. We have repeated x values, so this means that this is not a function. It's still a relation, but it's not a function. So you're going to hit no, and then hit OK. Beautiful. Okay. So for this next one, our equation is y equals 3 times x plus 1. And we're plugging in our input values, and we're seeing what we get out. So for the first one, we're going to plug in a -1. So the rule, right, is add 1 and then multiply it by 3. So we have 3 times -1 plus 1. -1 plus 1 is 0. 3 times 0 is 0. So our first output is a 0. For the next one, we have 3 times 0 plus 1, right? Our rule is add 1, we get 1, and then multiply by 3. We get 3. Our next x value is a 1. So we take 1 plus 1. 1 plus 1 gets us 2. 3 times 2 is 6. And then our last one is a value of 2. So we have 2 plus 1, which is 3. And 3 times 3 gets us 9. So our values here are 0, 3, 6, and 9. Make sure you have those plugged in. And when you're all set, push ahead to the next one. Alrighty, our next one has the rule 3x minus 5. So this is our function rule, right? We take some number, multiply it by 3, and then we subtract 5. So our first one's negative 1. So we have 3 times negative 1 minus 5. 3 times negative 1 is negative 3. Minus 5 gets us a negative 8. Beautiful. When we plug in a 0, 3 times 0 is 0. Minus 5 is negative 5. Now when we plug in a 1, 3 times 1 is 3. 3 minus 5 is a negative 2. And then our last one is 2. So we have 3 times 2 minus 5. 3 times 2 is 6. Minus 5 gets us a number 1. So for each of these, we multiplied our input by 3, and then we subtracted 5. Okay. All right, let's do another one. Go ahead and hit OK when you're ready. Alrighty. We have y equals negative x minus 7. So our first input is a negative 1. Careful because we're going to have this double negative here. So when I'm inputting, I like to put my x value in parentheses. So this is a negative 1 minus 7. Negative 1 is just 1 minus 7, which gets me a negative 6. When I plug in a 0, negative 0 minus 7. There's no such thing as a negative 0, that's just 0 minus 7, which is negative 7. Our next one is 1 minus 7. Well, negative 1 is negative 1 minus 7, which gets us negative 8. And then finally with 2, we have a negative 2 minus 7, which is a negative 9. Negative 6, negative 7, negative 8, negative 9. We notice this pattern that happens. These rules that we're looking at are linear functions, so we see there's this increasing pattern. And we're going to look at some examples of how we can notice and find that pattern in other functions. For example, for this one, we're going from 1 to 3 to 6 to something to 15. So we notice from 1 to 3, we're adding 2. 3 to 6, we're adding 3. So 2, 3, follow that pattern, add 1 more. 6 plus 4 gets us 10. And we can check to make sure that works because 10 plus 5 is 15. And 15 plus 6 is 21. So we see how it's increasing by an extra 1 each time. Beautiful. Go ahead and hit OK. Again, we're increasing. For the first one, we're going up by 5. And then 7 plus 5 again is 12. So we're going to assume this is also following that pattern, going to be plus 5, which gets us a 17. And we can see that, yes, that is correct. We add 5 there. We add 5 here. We see that pattern. For the next one, find the missing term. We go 1, 4, 9, 16, blank, 36. To go from 1 to 4, we're adding 3. From 4 to 9, we're adding 5. 9 to 6, we're adding 7. So we're adding each of these odd numbers. So the next one we're going to do is add 9, and 16 plus 9 gets us 25. So you're going to plug in 25 and hit OK. Beautiful. There's a few more questions here, and I know I'm about to run out of time, so I'm going to pause this video and make a short video for the rest. Okay, so check out part 2 to finish up this Thatquiz. Nice job, everyone.